Hello, everyone, and welcome back to the ARC 2021 Forum and the Cybersecurity Program. I hope you had a chance to attend our previous session. I thought that our speakers gave some great presentations, and I thoroughly enjoyed our panel discussion, though it was way too short. We had so many questions, which was wonderful. In this part of our program, we're going to focus on some of the new developments that are occurring in today's world of industrial cybersecurity, and I think that things that will have an effect on the future. Then hopefully they can help you shore up some of your own cybersecurity issues. Oh, I'm sorry, I don't know why it was so delayed, but in any case, before we do that, I want to get to, before I get to our speakers, I again want to thank all of our forum sponsors and encourage you to visit their booths in the exhibit area. You click on the exhibit tab on the lobby page of the fairs. I think they have a lot of interesting information to share with you, and I'm sure that they would be happy to discuss your unique security needs. Now, let's get to our set of distinguished speakers here who are going to give you some very useful information. I personally am very interested in hearing. The first speaker is going to be Jonathan Briney, who is a senior analyst in industrial control system security at CISA, which is part of DHS. And he'll be giving us an update on CISA and how they can help you secure your facilities. Jonathan's presentation at last year's forum in Orlando was extremely well received, so I'm sure you will find it very interesting. Our second speaker is Michael Hoffman. Mike is a principal industrial consultant at Dragos. And he recently joined Dragos after spending over 20 years at Shell and many of those years in cybersecurity. Now, he's going to give us an overview of the Mitre attack framework for ICS, which I see, at least I think, is gaining a lot of traction among industrial companies and active cybersecurity defenders. And our third speaker is Eric Byers, who's the CEO of Adalis. And Eric is very, very well known in our industry. He was the developer of the Tofino ICS firewalls, and he's a fellow at ISA, where he has been a long-term contributor to the development of cybersecurity standards. Okay, with that said, I'd like to pass the baton over to Jonathan now.
Good morning, good afternoon, good evening, everyone, wherever you are on this beautiful blue orb of ours. With these formats, it could be any time zone, anywhere right now, and we're all together to discuss cybersecurity and to learn some of what's going on out there. I'm going to present some of the campaigns we're dealing with, as well as CISA's current strategy. So we'll just jump right into it. CISA is its own agency now, so that's a beautiful thing for those of us who have been trying to work on that front. CISA is adopting a three-pronged approach to execution on the ICS strategic initiative. And how we're doing that is basically defend today, secure tomorrow, and then build strategic and operational partnerships with our constituents, the public, private, and governmental entities that we work with. So defend today. So I'm going to give you some examples of everything that we've been involved in recently. Obviously, you may have heard in the news, Director Krebs was talking about election security. We were one of the critical partners in ensuring the cyber front was indeed strong, and that we were positioned in multiple locations with multiple entities. We did a number of different analysis on devices, on networks, just really anything and everything you can think of cyber-wise to help defend the election networks, so to speak. And we feel like we were very successful on the cyber front. Past that, I dare not cast opinions, but on the cyber front, we feel like it was very secure, and we feel like we had a really good handle on what was going in and out of those networks for that campaign. As you're well aware, SolarWinds and the Orion software suite is a big issue. We're still currently embroiled in that. Many of you are well aware of that, as we are working in joint partnerships with you in some cases. We have by no means nipped this. It's still a very large campaign. It's ongoing. CISA has put out some emergency directives, which I guide you to the links at the last slide. There's some links that you guys can click on and get to the emergency directives. We've put out a number of papers on how you can locate this persistence that's likely hiding the versions of the software that are susceptible, the upgrades you need to switch to, and then as well as some additional methods and guidance for protecting legacy devices and such. So I encourage you, please utilize those links, go to our websites, get all the information you can. We've had a number of individual organizations that, while they have the SolarWinds software, did not feel they were impacted. I can tell you, if you had the software, likely you were impacted, okay? Do your due diligence, follow the guidelines, follow the information that we shared. We've done this with our Five Eye partners. We've done this around the world. We've provided this information. This is information we're culling from current ongoing engagements with our partners. So it's very valid, it's up to date, and we're giving you everything we have as quickly as we can get it digested, analyzed, and put back out there in a format where our partners and every one of you listening in can utilize it should you need it for your networks. So for Defending Tomorrow, we have a number of projects that are ongoing as we develop new strategies and new technologies. CISA is heavily embedded in the national labs and also with universities and think tanks around the world, really, as we go into the future, building on some technologies. Some I can't discuss here, but just know that we're working to get these technologies out there, make them more available, get them open sourced if possible. There's a number of initiatives we're working on, and we should see fruition on that front within the next 6 to 8 months. Sorry, it can't be faster. Unfortunately, with this being breaking technology, we need to make sure that it's safe for all of us before it's put out there. Things we can do to prepare. Again, we provide you a number of resources. Can we go to the next slide? That's Defending Today. We use the pillar, the 4 pillars is part of our strategy. You can read that on there on the slide. These slides are available for everybody to download, by the way. You'll have to forgive my voice. I'm fighting with some GERD issues. But these 4 pillars basically break out how we're attacking the protection of these systems, how we're building in our new technology and the stuff that we're doing at the labs and at the universities. We've got a bunch of sharp people coming up, so this is a good thing. Can I go to the next slide, please? The third prong is a pretty important one, and I call that one out the most because that's the strategic and operational partnerships. With the National Security Council, CISA was tasked to lead the coordination efforts to develop an operational strategic foundation for our national strategy to improve cybersecurity and control systems. As a result, the Control Systems Interagency Working Group, which has got the new acronym CSIWG, that's not at all confusing from the ICS-JWG. There's only so many different ways we can acronym this out, folks, so forgive me for that. It was established to enable a whole government approach in the development of this strategy. The CSIWG is working to develop partnerships across government and the private sector and is committed to improving cybersecurity for control systems. The CSIWG is under the Critical Infrastructure Partnership Advisory Council, or CIPAC, to allow for industry participation. So those of you that are members of the CIPAC, again, that's the Critical Infrastructure Partnership Advisory Council. So that is for our industry partners. This facilitates the flow of advice and information concerning critical infrastructure security, resilience, and protection. It fosters effective information sharing. It mitigates the risk of compromising vulnerabilities, promotes necessary communications during emergencies. DHS was granted a FACA exemption for CIPAC. Absent the exemption, CIPAC meetings would be open to the public, automatically disclosing any sensitive information presented in the meeting. So we got an exemption, so specifically talk to industry people, and it's not wide open so that our adversaries don't know, hopefully don't know what we know about them as quickly as tends to happen. Certain CIPAC deliberations are exempt from FOIA requests, and that is to protect you, our industry partners, from information that you share that can pinpoint who you are. We do still believe in keeping that information private within CISA, so that this encourages the industry partners to continue to share with us as we protect their information as if it were our own. And unfortunately with SolarWinds, that's not necessarily the best promise, but unfortunately we are all dealing with this in real time. We've added some new training, which will be out there eventually. ICS training courses and workshops provide hands-on virtual training to industry, government, and international partners. Classes for all skill levels. This new training that we're going to be offering out there. All CISA training courses are presented with no tuition cost to the attendee. ICS security basics, defense strategies, ICS cyber threats, and mitigations for vulnerabilities, and testing in a simulated control systems environment. These are some of these are instructor-led courses, which include Introduction to Control Systems Cybersecurity 101, 8 hours, Intermediate Cybersecurity for Industrial Control Systems 201, which is 8 hours, Intermediate Cybersecurity for Industrial Control Systems 202, which is 8 hours, ICS Cybersecurity 301, which is 5 days, and our newest ICS Evaluation 401, which is 5 days. That's right, 401 is here, folks, and we'll be offering it out there just as quickly as we can spin it up for remote attendees. CISA program training event consists of regional training courses and workshops at venues in various locations, in addition to the 5-day training events held in Idaho Falls, Idaho. We encourage you also to utilize our vulnerability assessments and our vulnerability management teams. They can do assessments using multiple different tools that we have at our fingertips to help you figure out how secure your systems are, where your gaps are, and then they provide you with mitigation strategies for those systems as well. I encourage you to take a chance and utilize this avenue of resource. Some very, very smart people in our vulnerability management branch, and I encourage you to utilize them to their fullest. We also still maintain our watch operations, which is where we're currently tracking the various campaigns that are ongoing out there. So we still do still monitor that, and we have a single entry point for accessing CISA support. If you can go to the last slide. This is just basically showing the contact. So you can click on that link and get a copy of our strategy. Visit that site and download the emergency directive for SolarWinds. I encourage it. I recommend it highly for anybody who has Orion SolarWinds software. It's also useful for helping with some legacy situations that I think there's some documentation in there that will help you protect those assets as well. I think that pretty much covers what I have for now. I think they're going to do questions at the end. So at this time, I will pass the baton to Mike. And I thank you all for your attention.
Yeah, excellent job, Jonathan. And as a former asset owner and operator, really appreciate all of the things that you folks are doing, especially on the excellent courseware that you folks put out and so forth. So yeah, again, just a big shout out to all the great work. So with that, a little bit, want to dig into the Mitre attack for ICS. Earlier in presentation 1, this is actually mentioned by Nathan. He talked about Mitre attack and being able to use Mitre attack in your environment. And so, really the purpose of the presentation is really to kind of familiarize yourself a little bit more with Mitre attack, and then how we can use Mitre attack for our strategy going forward. So not deep dive down into the technical ramifications of what this is all about, but how can we at a higher level view look at this, understand what has actually happened as far as attacks in the environment, and then being able to implement those lessons learned and those kind of things back into our program strategy. Kind of going into this a little bit, a little bit about myself. So yeah, I did spend a little over 20 years with Shell in oil and gas. Spent many different roles within that time period, such as what Ian talked about. Kind of started out as an instrumentation electrical technician on the plant floor, moved into automation and control systems, and then from there went into, of course, cybersecurity. So I had the kind of blessing of being able to do this in downstream and upstream different operations, and then of course did also kind of a global technical assurance type lead. And those kind of things across all lines of business. So, being able to see a lot of those different things. With Dragos now as a principal industrial consultant, what I'm doing is essentially helping companies out, helping them out with their journey and their maturity and those kind of things, doing assessments and tabletop engagements and so forth. With that too, just graduated actually from the master's program through SANS, great course. And then also I'm involved with SANS and teaching some of their classes. So very similar to like the, what we'd already talked about, the 301 and 401 course from INL. Of course, these are very similar with SANS, going into different aspects and those kind of things. So yeah, very happy to be able to begin to give back to the community what they've given to me so much. So again, just wanted to talk about this subject a little bit more on the TAC and really what is coming in the presentation. So first of all, kind of an overview of really what Mitre TAC is all about, and starting from the enterprise side and then moving down into the ICS side. And I think with that, when you look at the Mitre attack framework, you need to kind of understand kill chains. So I want to talk about kill chains a little bit and explore that topic, because the understanding of how an adversary actually goes into the environment, understands the environment, manipulates, gets credentials, moves laterally and vertically, and those kind of things. All of that comes back to understanding a kill chain. And then moving forward from that is getting into actually leveraging what has already happened out in the wild, if you will, and then map that to different activity groups. So there's activity groups that are tracked by numerous companies. And again, these are things that have actually happened. So this isn't things that you stand back and go, I wonder if this could happen to my environment. These types of activities have already taken place. So there's a lot of lessons to be learned from them. And then again, taking back and overlaying the mappings to different activity groups and looking at, how can we leverage these understandings and kind of do a mirror of what we have deployed out in our environments. Maybe we're, in our companies, we're doing very well in certain areas, and maybe in other areas we're lacking certain types of security countermeasures. So again, what is Mitre ATT&CK? So really, it's a collection, as I said before in the last slide, it's a collection of known adversarial tactics and techniques. So as you'll see in a couple slides going forward, a tactic is really the goal of the adversary. So maybe an adversary wants to learn about your environment or a environment, so they'll do reconnaissance. So then how they actually do the reconnaissance is the technique. So that's the more the detailed aspect of how they're going to achieve the goal of the tactic. And then also the Mitre ATT&CK has mitigations in there. So that's one of the nice things that they've added recently is different things about, so now that you have an overall tactic and an underlying technique, then what are some of the things that we can take from that? And what are some of the mitigations that we can actually apply in our environment? Now, this was really started by Mitre. But it's very much a community ran, a community contributed back. There's a lot of energy around this, especially when you think about from the enterprise side. Mitre ATT&CK Enterprise has been, it's I would say it's quite mature now. A lot of companies are using it, and very, very high maturity around that. A lot of vendors and those kind of things are mapping capabilities of their products back to Mitre. So it's pretty cool to see. But the ISS portion of it, has really only started just a couple of years ago, but it's really gaining traction in the industry. And again, a lot of end users are supporting it. A lot of vendors are now mapping their products back into the matrices. Now, with that, there are actually 3 different mappings that exist. And so we'll cover 2 of the 3 and definitely focus on the third one of ICS. But again, you have the ICS mapping, and then you have the enterprise mapping. And of course, there's a mobile mapping as well. But again, on this presentation, it's going to focus mainly on the ICS. But for that, you really need to understand the Mitre ATT&CK for enterprise, because this will help you to understand how it was, how the same understanding of the adversary was really taken and kind of placed down more the OT environment. So first of all, we look at this essentially it almost looks like a spreadsheet, and you can kind of create this yourself. But if you go to the Mitre website, you can absolutely work with this tool, all clickable links. But again, on the top, you see the overall tactics. And as I mentioned before, these are the goals of the adversary. So maybe the first goal is they want to do reconnaissance. So that is the goal is they want to understand the environmental more. How they do that is through the actual technique. So the technique may be Google dorking, if you will, or looking at LinkedIn profiles, or looking at different, OSINT or open source intelligence information. And so that's one of the tactics they may use or the techniques they may use for that tactic of reconnaissance. And then maybe they find out something about your environment or an environment, and they begin to develop the resources and capabilities. So maybe in a LinkedIn profile for a certain company, they saw that a certain software is used, or the person has experience in that software. It often ties that knowledge back into that. So an adversary may now go, okay, they're running this type of software or hardware in the environment, so they may develop out resources and capabilities. After that, may develop, for initial access, they may leverage like a phishing email. And so the tactic of initial access, that's the tactic, and the technique may be a phishing email or even supply chain compromise, such as we've been talking about SolarWinds, and that will be talked about for quite a while. That's another way of getting initial access. But initial access isn't the final goal. It's often now you've gotten in the environment, now you need to execute something. So you need to execute some malware. So you'll have a malware or a spoofed DLL, for instance, a dynamic link library or something like that allow you to get into the environment and get your malicious payload in there. And then, of course, you move over to the right-hand side and we see persistence. So again, how does the adversary stay in the environment for a long time? It's often through a persistent mechanism. How do they actually do that? It may be they, create a Windows task or something like that to load in a service or a malicious file that starts up on boot up, or even starts up in safe mode, for instance. And then, of course, you move on to privilege escalation, and we just keep going down to the right-hand side until we get a final impact. Now, the impact is really where we see a fundamental difference between the IT matrix and the OT or the ICS side, because the impact on the IT side may be, it's going to have a ransomware type of impact, or it could be, data exfiltration and those kind of things. So now, so again, that's how you kind of look at this, and we'll delve into this a little bit more on the ICS side. But again, it's good to understand this on how it actually works, and again, how these adversaries actually work through this, because that's where we get into the actual anatomy of an attack. Now, the ICS kill chain was really, it was a paper written by Rob Emley and Mike Asante. And what they did is they actually took the Diamond model, the Lockheed cyber kill chain, not the Diamond model, but it's something else. But they took the Lockheed Martin cyber kill chain, and they because that really talks about for an attack from an IT perspective. So what they actually did is they looked at that and said, okay, attacks down to our OT environments or ICS environments are actually quite different. And the cyber kill chain from Lockheed Martin doesn't quite deal with the intricacies of an ICS attack. But nevertheless, if you look at this, you can kind of think of an attack as a chain. And so you can use this from both from a adversarial or a offensive type perspective or a defensive perspective. So again, the kill chain very similarly links back up to the Mitre tactics. So you have, again, reconnaissance and weaponization, you have targeting into that environment, delivery of that malware, exploit of a certain vulnerability, install a certain piece of software or capability. C2 is command and control, where an adversary actually has remote control of that system or systems. And then you have an action leading into an impact. But again, this is all around the IT side. So if we look at this from an OT perspective or an ICS perspective, this is where really we go into that second layer of the Purdue model, or actually when we're getting into the Purdue model, if you will, and on layers 3 and below. And so essentially, once an adversary has gone into that space, they again have to relearn the environment often, and then they get into developing those type of compromises. They have to actually test it maybe in an environment. Maybe they have to acquire systems such as a PLC, RTUs, for instance. Actually acquire infrastructure to test out, and then they actually deliver that piece of capability back into the environment, install it, and then execute it, trying to get into a actual operational impact. So again, the stage 2 really discusses that ICS specific capabilities resulting in a real world process type of an impact, not just compromising a computer or compromising a system, but actually compromising the plant or the production process floor. So again, this is kind of another way of looking at it where, if you will, a stage 1 type of attack is on the enterprise side. And so that's very much where the Mitre attack for enterprise works well in that environment on the corporate IT side. But then when you bring into the stage 2 attack, that's where the Mitre attack for ICS comes into play, and it's focused down in that lower level. And again, you do have some overlap between it, Mitre attack for enterprise and Mitre attack for ICS. So just be aware of that when you're beginning to look into these. So now we get into Mitre attack for ICS. And again, if you look over to the left-hand side of this slide here, you'll see initial access. And so initial access, again, it's already thinking of that the adversary has compromised a certain part of the enterprise environment, and now they're actually getting into the ICS environment proper. So you'll have initial access such as a data historian compromise. Could even be like an engineering workstation compromise. So those systems used on the plant floor to interact, or maybe program systems and so forth. And it could even be external remote services. So you may have different applications that are being exposed to the enterprise side for moving files, perhaps, or moving, could be getting updates, if you will. Those could be compromised. And then, of course, we move over to execution. So this could actually be through, just leveraging what is in a Windows environment. So PowerShell, for instance. So an adversary is now got initial access. They're going to execute some software, something like that. They may be using a lot of built-in capability of the operating system environment. They may use just generic scripting and those kind of things. Trying to get persistence, and again, very similar type of techniques are being used here. Perhaps is on the IT side, but certainly a little bit more focused again for ICS types software and those kind of things. Then we see evasion, of course, masquerading against if you've heard of like evading against antivirus products or endpoint agents. That's one thing. And then of course discovery, where you're trying to discover those systems and adversary as through maybe they're doing extensive scanning, could be passive or active scanning in the environment to learn your environment better. Lateral movement, of course, using default credentials, which are very often used in the ICS space, or valid accounts that are already on those systems. And again, you just continue to move over to the right-hand side until you get to that final impact. Now, that final impact again is quite a bit different in the ICS than on the enterprise side. So the impact here is it could be a damage to property. It could be loss of availability of a system going down. Maybe it was a redundant system and both of them were taken offline, so that system is no longer available. It could even be loss of control, where a control parameter was changed perhaps. So a control loop no longer functions as it once was engineered for. It could even be loss of safety. So, and I'll talk about this in a little bit more, but on the Xenotime attack for a safety controller, where it was actually, trying to manipulate a safety controller, put in new firmware on that safety controller, so it would cause it not to function properly. And so that's, for me, coming from the oil and gas industry, one of the most scary things that you can think of is when your safety controller that has been properly engineered and built is now not going to function, or it's going to function in a way that was not intended. And again, different things like that. So when you're beginning to work with the Mitre ATT&CK framework, you'll begin to understand a little bit that there's a lot of information in here. So I already mentioned, like this engineering workstation compromise. So if you go to the Mitre ATT&CK website and you click on engineering workstation compromise, you can actually get a lot of good detail about these type of techniques, for instance. So here, there's each one of these has a technique ID that's associated with different things. Like with this one, there's an external contributor, Joe Slowick, formerly worked at Dragos, contributed a lot into this information. And then you also see, different examples, such as, the Stuxnet attack leveraged a engineering workstation compromise. The Triton malware with the Xenotime activity group, they also leveraged engineering workstation compromise. So this is where you can kind of begin to understand, okay, this is actually in the matrix. And then, so, who actually used this, what kind of activity group used this, and so forth. And then you can begin to understand what kind of mitigations are there, so that, that we can take back into our organizations and actually leverage and use. One of the things too is Mitre ATT&CK for ICS I'd say last fall came out with all of the different mitigations. So right now there's a list of 50 mitigations in there. And this is definitely, you can go in and search on that. And the nice thing about this is, such as account use policy, is the mitigations are linked back to standards. So standards or frameworks and so forth. So for account use policy, if you've seen that being used as the mitigation or listed, and you're trying to understand, well, what is the best way to do this, or what is one approach that our company can use, you can look, click on this. It'll show up and say, okay, now 853 from NIST references this. Also IEC 62443, 3-3 and 4-2 reference account use policies. So it's a nice way of kind of digging down into these attacks, what has actually been used in the mitigations, and then where can I go find those different things that we can take back. Now, this is where it really comes into play, where you can map to different activity groups. And so what I mentioned before was, well, like with Xenotime, again, they compromised, oil and gas facility in Saudi Arabia. This happened back in 2017, if I'm right. and really began to target that environment, looking for really the safety systems and really targeting triconic safety systems. And so one of the really nice features about this is that once an activity group is known, and again, how essentially the type of capabilities they use and how they're actually leveraging those capabilities in the environment, you can map those out into the Mitre attack framework and kind of get an overlay on how that attack really occurred. So if you're in the oil and gas sector, if you haven't already done this, this is a great thing to do to look and say, so this already happened in this environment. It could definitely happen, could it happen to myself in this environment, for instance? Now, again, there's many activity groups out there, not always focusing on oil and gas. Some are manufacturer. Quite a few of them are focused on the electrical sector. So this is just one example for oil and gas, but certainly it's one that we can, I think we can just apply, and it provides a nice framework on how this actually occurred. But if you see here that as the activity group, or as they targeted the environment and went over, they finally caused an impact of a loss of safety. Now, one of the things, with that is that, okay, so now that we've overlaid these attack paths, and this is really bringing it back home to, into your own infrastructure, is you can go, okay, so they leveraged engineering workstation compromised. So how did they do that, and how best are we in our environment, in our organizations, at our facilities, how best are we prepared to protect those critical assets, or detect certain types of activity, or even respond to those types of activities? And so, this is just one example of, you may look into your environments and look at the engineering workstation compromise, and if you dig deep down into it, you can understand that, you may already have endpoint protection being used. So it's kind of a green check. You're doing well. Host logging may be enabled, which is great. But host hardening may not be done very robustly throughout the environment. You may not fully understand where your systems have been set up, how they're set up, the security mechanisms turned on, if you will, or there are certain protocols disabled. And that's really comes down to host hardening. So that may be an area where you need to focus a little bit more. Maybe you've looked into your environments, you've done the proper segmentation, such as leveraging 62443 from IEC, great standard for that. But maybe from an aggregation perspective from your logs. So even though you have logging enabled, you're not looking at those logs from a centralized perspective. This is one area where a lot of companies are struggling with, is even though they have logs enabled, they're actually out on that device, and you have to go to that device to get those logs, which is, again, takes a lot of time during an incident response type scenario. And even, network monitoring. So even though you may have, logs enabled, you can't see that traffic that's, that malicious type activity traffic occurring in your environment. So those may be some areas you want to focus on, as you look to, doing, improving your strategy and your maturity profile. So again, this is just some ways of looking at this, and you can do this for each one of these elements. For external remote services, you can definitely look at in your environment, say, okay, where do I have remote services? What ports and protocols am I using? And those kind of things to really understand your security posture. And again, just kind of wrapping, and again, definitely put these back in your program strategy. So really wrapping up here, just want to encourage you to leverage these, I'd say, amazing resources that are already out there. So again, on the IT side, most teams are already leveraging enterprise, I would say. It's probably rare to find an organization that's not, or hasn't heard, or is using certain elements of the Mitre attack for ICS enterprise. But certainly, just want to restate here the importance of just having this capability of the Mitre attack for ICS, so that we can again be looking into these areas, these critical areas in our infrastructures. And again, the importance of mapping activity groups. So this is leveraging, again, intelligence from what has already taken place. We don't have to go to, we don't have to have a leadership conversation asking, could this happen to us? What certain things should we be working on? We can look at this and say, this has already happened. can it happen to us? And we need to begin to overlay these capabilities and determine, are we prepared in our companies? And then again, once you do that overlay, you can identify those different elements of security capabilities, protective capabilities. Certainly, if you can't protect, you must detect. And then, of course, response gaps and those kind of things that we have. And also, a good recommendation is to start with, kind of sooner than later in the attack chain. So as I mentioned, how kind of attacks work, it's a link of a chain. So if you can focus, more on the left-hand side, if you will, of that chain, break the chain earlier, it'll have overall less impact into your environment moving forward. And then again, highly recommend to champion those projects and efforts to resolve gaps. And I've definitely seen, and again, at a large organizational level where, so we've identified these gaps and we've identified these things that we need to go do. Now, how do we go do it? Where do we start? And so I definitely recommend starting small, starting with your high value facilities or your critical areas within your facility, putting in those capabilities that you've determined already from the mapping exercise, and then of course getting lessons learned from that and rolling out from that aspect instead of doing global projects first and learning from a big scale. Always start small and can move on. So with that, I'll leave you with a couple different resources. Here's a Mitre ATT&CK link. Just to be aware, the Mitre ATT&CK for ICS is actually a different URL. So just be aware of that. And then, of course, from Dragos, we do offering that if you go to our website, there is actually an activity groups with the mapping already done. And it's just a nice web page where you can click along and you can select an activity group, such as Xenotime. It'll actually map it out for you. So you don't have to do this by hand with a spreadsheet. So definitely recommend looking into that. And then also, if you haven't read the paper from ICS Kill Chain by Rob M. Lee and the late Mike Asante, highly recommend you looking into that paper from SANS. A lot of good material in there, a lot of value add to your company. And with that, I would hand it back over to Eric Byers, and he'll take us on from the next presentation.
Great. Thanks very much, Mike. That was really, really interesting stuff. I'm quite impressed with that whole Mitre program. It's been really useful for us. So I'm going to talk about something different, and we're just going to start doing a little screen sharing here. All right, and hopefully everybody can see that. So I want to talk about the SolarWinds attack, and particularly I want to talk about what the whole fiasco is going to do to the industrial control system landscape. Even if you don't have SolarWinds products, this is going to change your life over the next few years. So, and I'll explain why. So fasten your seatbelts. This is going to be pretty fast. There's a lot of materials here. And the SolarWinds attacks is rather interesting and complex. So let's start off talking about SolarWinds itself. Now, most of you are pretty familiar with the fact that it started off, sort of started off, I'll talk more about that in a second, with a very well resource skilled attack group getting into SolarWinds, a company that supplies network management tools, getting into the development center and replacing the code in a particular package called SolarWinds Orion Core Business Layer with basically what was malware. And of course, once they were inside SolarWinds and once their code was inside the SolarWinds product, then the next thing that happened was, of course, that SolarWinds handily distributed it for them, doing their dirty work and infecting 18,000 customers. And of course, it was super effective. That's why it's so famous. 425 of the Fortune 500, all the US telcos, all the branches of the military, all the 5 accounting firms, the Pentagon, the State Department, just everybody who's anybody ended up having this malware on their system. And surprise, surprise, these attackers started to mine that. So, but it's not that simple. That's what was really interesting. First of all, let's start talking about how they got in there. We talk about the SolarWinds software that was actually inserted onto these sites, but before that, there was some malware that's affectionately known as Sunspot, designed specifically to get into the SolarWinds Development Center and allow the attackers to inject code into the software being distributed. So that's Sunspot. Now, Sunspot's job, again, be very clear, is not to infect anybody else but the development center, and put Sunburst, or also known as SolarGate, into this code that SolarWinds, a legitimate company, is distributing. And so SolarWinds distributes that. All right, they send it out to their client base, 18,000 of them. And what does it do when when the Sunburst is on your website? Well, after 14 days, and if you're a target of interest, Teardrop is executed, and Teardrop is a dropper, also known in one version as Raindrop. And droppers leave attack software on, they're the delivery mechanisms. So what does Teardrop drop? It drops something known as Cobalt Strike, which leaves another package called Beacon. And if you've ever used Beacon or bumped into Beacon on a red team, it's an amazing Swiss Army knife of attacks. It's got command execution, key logging, file transfer, SOX proxying, privilege escalation, Mimikatz, port scanning, it goes on and on. Just consider it, once you've got Beacon on your network, you've got a problem, and your bad guys have a foothold that is just amazing. So that's the guts of it. And you can see, so this is really the guts of a very complex attack. But it's not that simple, if that was simple. One other thing I should mention, we'll go back there, is once Beacon's on there, then it's manual, hands-on, driven by the attackers. Okay, so there's more to this. There's another piece of malware out there known affectionately as Supernova. And this is a really cool web shell written in C#, and it's specifically for use on SolarWinds Orion servers in their clients. This is a DLL that masquerades as a SolarWinds legitimate DLL webs called App Web Logo Image Handler. And I'm going to come back to this later. Anyway, this is a cool little tool, or executable, or whatever you want to call it, because it allows you to run as an attacker any arbitrary chunk of C code on your victim. You send the C code you want, and your victim compiles and executes it on their server in memory. So you don't even leave artifacts laying around. You need a port scanner for a special protocol, write it, test it at your site, then send it off to your victim and have it compile and execute it. Very powerful tool. However, it probably wasn't written by the SolarWinds attackers. So there's somebody else playing around here too. Most people who've studied it think it has been built by somebody else. Who? We don't know. But wait, there's still more. About 30% of the private sector and government victims don't use SolarWinds, have no connection to SolarWinds. So how are they getting affected? We don't know at this point. I'm going to guess that there is still a lot more to be discovered, and still a lot more supply chain attacks and holes in the system. We're just looking at the tip of this iceberg, unfortunately. Let's have a quick look at that timeline. Okay, this timeline is dragging on from September of 2019. So what is that? Almost 20 months ago, when the attackers start going after SolarWinds. They start injecting test code, and they're very professional. They inject test code into the SolarWinds development centers. They stop testing that around November. At that point, the SolarGate / Sunburst backdoor is ready. They've tested it, and now in March of last year, almost a year ago, they start having SolarWinds distributed to their customers. At the same time, they're doing some target profiling to pick off which companies they think are highest interest. End of May, they start using that tools. They actually start doing the hands-on attacks. They activate Teardrop. Teardrop drops Cobalt Strike and Beacon. Beacon allows them to do all the cool tricks they have. Interesting enough, the attackers at this point are, by June, they're so sure that they've penetrated enough sites, they start stripping all their malware and cleaning up their SolarWinds sites so that nobody can find them later. And they keep doing this until December 12th. So what is that? 7 months of uninterrupted access to sites. This is a supply chain attack of incredible success, as I'll explain in a second. But look at the amount of time they have here with on 18,000 different sites. In fact, with 18,000, I think that they were drowning in opportunity, because they only actually activated Teardrop in a relatively small number of victims. The rest they just let go, including some pretty high value targets. Who did it? Oh, well, that's the $60 million question. What we know for sure, they're highly skilled. I've looked at some of the code. I've looked particularly at what was done on the supply chain side of it. It's exceedingly well written. It's well resourced. This is a professional team. The quality assurance is phenomenal. Their mechanisms for communicating back out to their command and control centers is first class. It's clearly a nation-based group. I don't believe anybody has the resources other than the nation. And if you're FireEye or Microsoft, you call it UNC 2452 or Dark Halo or Stellar Particle. We don't really know who it is. We just know they're darn good. And we know they're run by a nation state. The CISA and FBI and NSA have issued a statement saying they're probably Russian in origin. And Kaspersky has also noted that the algorithms used match the algorithms used by the Turla espionage group. So at this point, we don't really know who did it, but we've got some hints. Regardless, it's the real takeaway point here is that it was really well done. And by the way, everything I've just said there about, it could be false flags as well. It could be a different espionage group, but it's definitely somebody nation-based and skilled. Okay, let's move on to what this means to ICS. And you may be saying, well, this is an attack on a network management system, and we don't use that system. Well, it's still going to impact us, and let me explain why. First of all, look at the return on investment for these attackers. You attack one company, SolarWinds, well, and you get 18,000 victims of the highest value possible, and you get deep penetration into them. Now that's return on investment, and you get to do it for 7 months undetected, just open season. That's return on investment. And professional attackers work on return on investment, and the entire hacking community knows this, and they realize that supply chain attacks are the next wave, and we're seeing that everywhere you look. You're seeing supply chain attacks. They're up over 400% in the last year. Why? Because they're effective. If you can get in between your supplier and its customer, you have an attack that is unbelievably effective because you're taking advantage of the trust that we have with our vendors. And nowhere is that trust more important than in the ICS market. We absolutely have to trust our vendors, and these guys are taking advantage of that. The second reason is that, unfortunately, it's easy pickings in supply chain. While we've got some really good models on how to secure our plant floor control systems, there are really no good models on how to secure the supply chain. This slide from the Atlantic Council, which I'll talk more about in a minute, goes through just all the different opportunities that we have today, or attackers have today, in order to get into the supply chain. And it can be direct attacks and injection like we've seen there, or it can be things like messing around with certificates. And speaking of certificates, well, remember that the original ICS attack, Stuxnet, was all based around stolen digital certificates. Here's a sad example of how something that is supposed to be helping us and protecting us is actually starting to cause part of the problem. And it's nothing wrong with digital certificates themselves. It's just that they're being misused and misunderstood, and they're actually being exploited by the bad guys. They're being exploited so much that statistics I've seen show that there is more malware now signed with digital certificates than there is regular software. So I'm not saying throw out certificates, but they're not enough and we have to clean them up. And that's not going to be easy. Now, in our space, we've had our share of straight up supply chain attacks like this one. You guys have probably all heard of Dragonfly. If you aren't, I'll give you a quick tour. Again, taking advantage of that supplier user trust. It's 2014. And the cyber attackers go after 3 vendor websites in the ICS space. These are mid-tier vendors supplying things like VPN concentrators for the plant floor, motion cameras, and industrial manufacturing motion cameras, protocol converters, stuff that you use deep on the plant floor. And what do these guys do? They go in, they attack these vendors, they replace the legitimate upgrade software packages on these vendor websites with versions that now include the malware called Havix. Now, one of the things we've done well over the last few decades is teach our technicians to patch early and patch often. And so the technicians see that there are new versions. What do? They download them. And on the one company that I work quite extensively on an analysis of, one of the victim vendors, we saw that the malware resided on their website for distribution for about 3 weeks. 280 technician downloads were made at that time. And if those technicians are downloading the software, you can bet they're installing the software. Nobody downloads software just to keep it on their hard drive. They're putting it right into the plant floor. And as we studied it, we saw people walked it around their firewalls. It was an amazing piece of coding. I could go, but it absolutely bypassed all the security tools that we had. And of course, once it's installed, probably at least 280 industrial facilities, but I'm sure if you download it once and you're a technician, you'll be installing it on all your facilities, but at least 280 facilities ended up calling back home to those attackers. So I want to sort of stress here that the return on investment for attacker makes supply chain attacks the most attractive attack today, along with ransomware. Now, speaking of ransomware, you can combine them. You can do really cheap, dumb stuff like this. Take a classic ransomware package, your stock ransomware package, rename it as Allen Bradley Update, and start shipping it out. Not fancy, just in this case, you're just taking advantage of the name. It wasn't even well written because Allen Bradley doesn't ship packages called Allen Bradley Upload. If they'd even tried to go and look at what a typical Allen Bradley update looked like. But obviously they didn't need to. Obviously this was successful enough for them. So what I'm telling you, the one takeaway here is get ready. We're in for a wild ride. We are going to be seeing supply chain attacks as a regular problem in the ICS sector. So what are we going to do about it? We need to address this. We can't just stop trusting our vendors. Our vendors are critical to safe, secure ICS. But at the same time, we need to find a way to secure our supply chain. Well, there's a really good analysis of this by the Atlantic Council that I highly recommend reading. I'll talk more about that later. And they make a bunch of recommendations. And the first step contains these 5 recommendations. First of all, we should be building a supply chain overlay to the NIST security standards. So this is something industry and government need to get together on, and then we need to do something with that overlay. I mean, we have good standards for, again, industrial control systems, software development, etc., but supply chain, we do not have any standards. Then the other thing they recommend, bring it to the cloud because the cloud is part of our life. The last 2 items, though, really are what I'm going to talk about today because I think it's the short-term gain that we can get right now. Standards take time, as everybody knows. One is integrating the software bill of materials standards. Let's get software bill of materials. What are software bill of materials? I'll tell you in a second. But once we have software bill of materials, start releasing tools to make it possible to have software bill of materials. Now, I promised to tell you what a software bill of materials is. Well, it's basically an inventory, a list of ingredients. What are all the components that make up a software package you have loaded or about to load onto your control system? Whether it's loading an HMI or a data historian or a PLC, you're loading a pile of different components from different vendors. there's a number of good standards, SPDX, Cyclone DX, SWID, and there's a whole government body looking into this called NTIA, called the Software Component Transparency Framing Group, which is an outstanding little group working on that, and very involved along with a number of the vendors here this week. So this is super important for ICS because we have a lot of ingredients in our stew. We're actually in higher risk for supply chain attacks than the IT world because our software is so complex. We're never just running on a Windows box. We're never just running a few simple protocols like HTTPS. We have got such a complex stew that we have to depend on other suppliers. So that collection of different suppliers means that we really have to know what is in the stew if we're going to secure them. Now, just like if you went and go to the grocery store and you pick up some product like a soup, a package of soup, and you read down the side and you see all these ingredients, just knowing there's ingredients in it isn't helpful. You really have to understand the ingredients. Is that ingredient a good ingredient or a bad ingredient? Does that ingredient cause a chance of cancer? Or is that ingredient something really healthy for you and it's going to have antioxidants and you're going to be healthier for it? So you have to be able to understand the ingredients. And in order to do that, we need to do a couple of things. Whoops. And we jumped a few here. Let's get back. Wow. Okay. So what do we need to have SBOMs do the job? First of all, I know we have a lot of resistance to cloud sometimes, but this is a place where we've got to use cloud because all the databases and all the vendors, everything, when you're trying to learn about a component, you're needing to go to antivirus sites, you're needing to go national vulnerability databases, you need to go to the vendors to find out whether that component has been, is no longer current and is out of date for one reason or another. So you have to have at least some cloud component to this. You don't have to run the cloud, the plant floor from the cloud. That's certainly not the case. But at some point or another, you're going to have to do lookups in the cloud. The second thing is these lookups are complex. We look at a number of different databases. Take the name Rockwell Automation Inc. We have found 50 different ways to spell Rockwell Automation Inc. or state Rockwell Automation Inc. 50 different ways. Some of them are obvious. You forget to put ink on it. You forget to put the period at the end of ink. And some of them are just absolutely so mangled. So if you want to look up Rockwell Automation Inc. for a component, and in these different databases, you can't just use the name. So this is where you really need machine learning to do that correlation. And the other thing you really need is a graph database. Graph databases are different than relational databases like SQL, because what you're trying to do is build that chain of relationships. Oh, here's a component. It's being used in one place. Where else is it being used? Where did it come from? Does it have components? That ability to build trees is absolutely critical. Now, why do we want it? Well, I'm going to give you one example from SolarWinds. Remember that DLL I mentioned earlier? How do you know if it's in your plant? You're going to go and get everybody to do a search of every single drive on every HMI everywhere in your plant? Probably not. It's not very efficient. In fact, how do you even know if you have SolarWinds software? I know that certain vendors major vendors use SolarWinds software, particularly in the power industry. I'm not sure their clients even know they have SolarWinds software on their plant sites. So this is really important, and Pushkar Tiwari, who's the director of development at Symantec, said it very well. He said, to know if you've been affected by the hack, he's referring to this attack, SolarWinds, a detailed assessment needs to be done for your software inventory. We're still learning to do asset inventory for hard things, like physical hardware. We need to do it for software, and it needs to ensure the code is not used in the environment directly or indirectly. Keyword there is indirectly, and only way we're going to be able to figure that out is with these software bill of materials. We're a couple of reasons, other things that we're really going to, why we need to use this, these software bill of materials. First of all, ICS vendors, this is hugely helpful for them to track their dependencies and understand what, not only what suppliers use, but who are the suppliers to their suppliers, you know, 3, 4, 5 layers down. They need to know that when they ship it. And that allows them to manage evolving third-party issues and really help their customers meet, validate their software, and meet their regulatory requirements like NERC-CIP. The other thing is the asset owners. Anybody here who's an asset owner, if you don't know what software is running on your plant floor, you're really going to be struggling to do vulnerabilities. On Wednesday, Brian Owen is going to be talking about how he helps companies do that, how he's working with my company, Adolis, to use software bill of materials specifically to help his customers figure out what the priorities are. So I highly recommend catching that session on Wednesday. And then, you know, you may be in a regulated industry that has prohibited third parties or prohibited nations. You know, like in the US, clearly we have some regulations around companies like Huawei. I mean, do you even know if you've got Huawei software? Yeah, sure, if you got a box saying Huawei on it. But the reality is that Huawei software gets embedded under lots of different names in lots of different products. So that's really critical. And finally, if you're a security analyst doing that kind of analysis that Mike just talked about, it's really critical that you understand how the attackers are going to be able to live off the land by knowing what components are on that plant floor. If you're trying to do threat hunting, malware hunting, you absolutely have to know what's on the plant floor. Actually, before this next slide, I want to say that this is up and coming. It is becoming a requirement to have SBOMs in the regulated utilities. Again, Brian Owen will be talking about how OSIsoft is using SBOMs for their customers. It is going to be what we're going to see in our industry. But it's interesting in the financial industry. I heard this talk by Sunil Yu, who's the former chief security scientist of Bank of America. And he talked about how the banks are saying, if you don't have an SBOM transfer or an SBOM for us, you're making our life risky, Mr. Manufacturer. And therefore, you are going to have to give us a discount or give us extra support or guarantee security. So we're starting to see where SBOMs are absolutely critical. Now, this is going to be tough. I'm not going to kid you. SBOMs aren't just something you can whip up. For the last 3 years, I've been building tools to make SBOMs easy to create, my team and I. So if somebody's got questions about SBOMs, if you're a vendor and you need SBOMs, give me a shout. If you're an end user and you want your vendors to start supplying SBOMs, I highly recommend that. Give me a shout. I can give you lots of pointers, because the road forward is well said by Vasu from Microsoft. These attacks are going to get more sophisticated. This is not the last. It certainly isn't the first. And this is the norm, and we need to deal with it. If you want to learn more, there's some really, really good papers out there. They're easy reading, and they really give you the background. The Atlantic Council paper I mentioned, Breaking Trust, is a great white paper on securing the supply chain, and explains the risks particularly very, very well. And then Sid has done an outstanding white paper on supply chain risks and managing them. Just a great paper. And then again, Wednesday, Brian Owen is going to be talking about this as well, and how OSIsoft is actually using supply chain tools and supply chain techniques, such as the FACT platform, in order to help their customers. So thank you very much. At this point, I'm going to hand it back to Sid, and we're going to have some chance for some questions.
I think you have to, there you go. There you go. And Jonathan, do you want to, there you go. Okay, we're all here. Great. Boy, that was great. Those were great presentations, guys. I really enjoyed this. You know, the one theme, I know there's a lot of specific topics here, but there's one theme. I mean, I personally, maybe it's one of my little things, But you know, the solar winds issue, I think, is so pervasive, but I think it can play into everybody here. I wanted to ask, give everybody a chance. But let me add one little thing to it. Well, first of all, let me make a comment I want to make for everybody who's watching. Traditionally, it's a rule at ARC, pretty fixed, that the people we get to give presentations are end users. We're very proud that that distinguishes our conferences from others. Now, when you look at this, the two you're seeing on the left right now, Eric and Mike, both work for companies, but I want to compliment them because I said to them, look, we want you to talk about this because we really think you know that topic and it's a very, very important topic. But please try to keep away from doing any promotional stuff. And I want to compliment them. They both did a wonderful job of that. So for any of my suppliers, please don't come back and complain to me that I had suppliers talking here. They were not doing sales pitches here, though they both could. They could both do very good stuff. I mean, their companies have very good products that they could use to promote. Now, back to the solar winds thing. One thing I thought there, you know, I mean, yeah, that really has caught my eye. But I wanted to tie together, if we could, to a couple things. One is, and I'm just going to frame it, and then we can go around and talk to it. One is, is there a benefit to the Mitre attack framework to help to defend against those kinds of issues? I'm not sure there is because they're kind of under the cover here. They're nothing that I've seen in Matrix. Maybe I'm wrong. Maybe there's more there. Another thing is, if you were in the first session we had, you know, I personally am a big proponent and a big believer that we're going to see IT and OT starting to converge more and more. And that's going to bring a lot more sophisticated cybersecurity capabilities into the plants. I mean, I think we need it. And, you know, there are things that I was saying, like, you know, even things like access control and end-to-end security and trust. I mean, right now it's all broken up in pieces. So this one might be good over here and then the next person is bad. So I'm wondering how, and then Eric made the comment about that it's much worse in ICS than it is in IT. And I'm not so sure of that. I don't know personally, but I'm not so sure. I know everybody knows I'm an old automation guy, so I favor that, but I'm maybe being pulled to the dark side here. I don't know on the IT, but I don't think that IT is necessarily that much easier from that perspective. Particularly today with digital transformation, there's so many apps that I think we might call IT things, even though maybe IT wouldn't want to call them that are using all these components from all over the place. It's kind of the classic example of supply chain things. Now, I've taken 5 minutes here or whatever to frame the problem. I don't know how to let you comment on that, but I want to give each of you a chance to comment on that. And also, in the case of Jonathan, you know, let me just one other point, and that was this thing that Eric raised that I was going to raise anyhow. I'd written it down as a question for him. Was, you know, the recent announcement from CISA that, oh, by the way, a lot of these attacks aren't happening to anybody that uses solar winds. So I'm wondering, well, okay, if that's happening, what is it that they're being attacked? I mean, I understand it's something in solar winds, but is it actually the same software that was embedded in solar winds or is enabled, or is it some other way that it's being associated? That's what I'm trying to understand. So let me ask Jonathan first. If you can comment on that and just share something with me.
Yeah, I said at this time, I can't really talk about some of those issues. We are working on getting out something that will answer that question specifically. Best bet would be to guide people to our CISA media email where questions can be asked, and if they want to do an RFI, a request for information, they can do so, and then that way we know who we're giving the information out to specifically. As we have built up trust with a lot of the industry leaders, and we do give that information to specific individuals within the industry. I would recommend that those questions be guided to.
Are you done?
To them, so that.
I think we lost you.
Yes.
Oh, okay.
What?
Yeah, but let me just one question. Hopefully you can share. I mean, I'm not asking you to share anything specific, but is it other malware that is related that people are finding in systems that is, again, maybe you can't comment. I don't know. I don't want to force you into a position you can't comment on.
There's a suite that kind of goes along with this, and it's cloud related. So those specific instances are what we're addressing right now, trying to figure out exactly how that was accomplished. And we have inroads into that. We're working with those cloud providers specifically. So again, Sid, we'll have more information on that as it comes to pass. I apologize.
No, that's fine. I understand. Michael, can you comment from the point of view of the Mitre framework? I mean, maybe it helped, maybe it won't. Doesn't mean that Mitre framework is bad if it doesn't. I'm just asking the question.
Yeah, I mean, yeah, definitely. So the Mitre framework does have a section in there for supply chain compromise. And another thing too with the Mitre framework, it's constantly evolving. So as attacks like this come out, they'll be thoroughly researched and put back into the framework too, as more examples and other mitigations will be able to had. So certainly, if you say, well, let's pivot into Mitre attack right now and understand this, well, it hasn't been mapped out yet. It's coming. I think another thing too is when we look at this, it's so there's a lot of, I mean, we don't know what the future holds, so we can't detect all certain types of software and those kind of things put in our systems. I love the idea of a software bill of material though, from a former end user and operator.
Yeah, me too.
But when you think about this, so when this attack occurred, when that malicious component was placed in the environment, all of a sudden you had new communication take place. And so for people that actually knew their environment, so as Eric talked about, proper asset inventory or asset visibility, if they actually knew their environment well from a hardware and software perspective, and also were able to detect those communications that started to occur, those command and control communications going out, that could have really, helped them to hone in really quickly to understand that, really what is going on in the environment. We definitely need to move back to detecting this stuff early, and definitely being able to vet the kind of software that we put in our environment. But if we miss it, we have to be able to detect those type of activities going on. With that, I'll pass to Eric.
I was smiling. I don't know if I'm smiling, if you could see, but I just recently saw, I don't know what company, maybe FireEye or something, but anyhow, they said, you can't just have ICS and IT, you got to combine the two. And there's an argument for that, which I think has a lot of sense, but it took the Mitre attack framework, your picture, from being this wide to being this wide. And now when we add in supply chain, it'll be that wide. And everybody can see, you can't see what my hands are because there's no end to it. So anyhow, that'll be cute. But okay, Eric.
Yeah, I think there's a couple of things. Mike made some really good points. We can't just say, oh, well, we're going to protect the supply chain and ignore the monitoring on the plant floor. This has to be done using all the tools we've got, because the bad guys are using all the tools they've got. And I do think that this current attack is going to change the Mitre framework. There's no doubt. But as Jonathan points out, and I'll point out, we're still learning, guys. This is we're going to be learning for another year, just like we had to learn on a few other attacks. Unfortunately, the bad guys are learning too. So I think that's really important. The other thing is that we've been a little, and I can blame myself a little bit for my focus on firewalls. We've been a little bit focused on, sort of detecting or defending like deep in the plant floor and not really sort of being more proactive. I do think the cool thing about supply chain is it's going to start to let the vendors, the customers work better together to actually have more of a proactive security solution, less of a reactive solution.
When you, with the terms you just used, it just reminded me of the other questions. In my presentation this morning, I made the big comment about people have to shift to active defense. What I call active defense, I know there's some people mean active defense is counter attacks, and I don't mean that. I just mean, monitoring, detecting funny things, and responding quickly. But actually, in this case, I'm not so sure that there were any indications that anything was being exploited. I mean, maybe these in IT, maybe they could detect that things were being sent out of the corporation that shouldn't have been out of the corporation, or I don't know. But it seems to me, because of where it was running and how it was running, the little what I know about it at least, it wasn't almost undetectable. It wasn't like, maybe I'm wrong.
Yeah, there's Microsoft has a great couple of blogs where they point on the complexity. I mean, this is a complex attack. It's using, you look at that kill chain, and they've got a long kill chain. And as I explained, it's got 4 or 5 different components in it. And so back to the Microsoft thing, they had a really good blog that explained all the points where the attackers could have been detected as they were modifying code and basically loading code and loading new code and communicating back. Obviously, they weren't. I mean, they got 7 months of free run, so we got to do better. We can't, we can either give up and throw up our hands and say we'll never stop them. But I do think in time, just like we've seen in physical security, that we'll get to the point where our detection mechanisms all the way down that kill chain are better. And then as a result, it's going to be harder and harder for the bad guys to launch a really complex attack. But I mean, honestly, we need to be doing the detection before the software is installed. We need to be doing the detection when the software is sitting in the vendors' development centers. And we need to work together. I mean, that's the really important part.
Yeah, we had a question from the attendees with respect, I'll read it to you, but I think I know the answer, but anyhow, regarding the software bill of material, is the proposal to have this information provided by vendors or searchable online in some sort of consolidated database? And I think, Eric, your answer would be, come to my talk, come to my booth, and I'll explain to you.
Yeah.
Just doing searches is too hard, so.
Yeah, I mean, you're absolutely right. What we're proposing, what we've been building the last 4 years is a searchable database that at the same time doesn't give away the farm for the vendors. Vendors have IP they want to protect. So it's not just like, have everything you ever wanted, but on the, just share everything out there. This is not just take all your clothes off. It's really a matter of like, a searchable database, but at the same time manageable to really disclose the information that's going to help defend our systems.
I have a couple other questions here. One from Anna. It says, Mike, this is to Mike. One of the biggest challenges in the ICS world is effective endpoint protection, which most virus applications are not as effective because of program exceptions. I don't personally know what that is. It's in quotes. Can you weigh in on that effectiveness of EDR on ICS? And Jonathan, you can comment as well. So,
yeah, I'll go first, and then let you chime in on that as well, Jonathan, to see where your views are. Yeah, it's an excellent question. So when you do look at deployed antivirus, so I'm going to focus on antivirus because that's what most of the vendors are using, or is what they're testing out and qualifying, if you will. So yeah, when you look into those, and that's a great question by Anna around this, because a lot of those will have exceptions or exception lists, and sometimes those are massive file paths where a vendor will install their software and the entire directory is exceptioned out because the amount of information or data changes so fast that if an AV tool were to scan that continuously, they would have a lot of processor utilization issues. So that's really that question. So a couple things I see there is one, AV is always looking backwards. There is heuristics in it, those kind of things, but it's, we'll never be able to detect future with that type of a product. Now there's a lot of capabilities coming into a lot of these software products that with heuristics and those kind of things, that you're able to catch new type of signatures, or not even signatures, but capabilities that don't, that are beyond a signature, if you will. So there's that aspect. But another thing too I see is that a lot of those exceptions can be tuned. I've seen a lot of those deployments where people don't know, so they'll just open things wide up. And also around how often are those signatures being updated. So we see a lot of deployments where they put in AV or put in some sort of an endpoint protection product, but it hasn't been updated in over a year plus. So I do see that the effectiveness of that solution is, one, properly tuned, and then also properly updated and properly monitored. Because even if you have a tuned endpoint and it's properly updated, are you actually monitoring those events occurring, or is it just from the operations folks saying that I saw a pop-up on my console and they call somebody? That's not a proper escalation path. Yeah. So And I also see, around, when you think about endpoint protection, also whitelisting, there's a huge advantage on whitelisting. Our environment doesn't
Huge.
change very often. In the ICS, it does change, but it's not that often. So whitelisting, if done properly, is also a great, add-on to that as well. With that, I'll pass it over to you, Jonathan.
Mike, you hit it right on. I was going to bring up the whitelisting. That is so key. And as far as the AV, yeah, we kind of feel the same way. It's always kind of backwards looking, which is 2020. That's great, but we need something that's more predictive. And those are the type of technologies that we're working with the national labs on developing, those type of systems that are going to be able to look at your system. And because your system doesn't change, these technologies are highly suited for that sole purpose. And yes, they're going to be semi-intelligent, semi-autonomous, but that's what we really need for these systems. And in the case, like we're seeing a lot of this ransomware right now, and they're really starting to come after ICS networks. And then you hear the companies say, well, we don't really. The ICS doesn't affect the ransomware doesn't affect our ICS networks. True, in 90% of the cases, the actual ICS components themselves may not get the infection. But as you all know, if you lose SCADA, your oversight, you can't safely run it. OSHA makes you shut it down. So, what's the cost for you to shut it down until you can visually inspect it? And we've had to work with several instances recently that's happened. And when you start talking about $15, $20 million a day in losses because they can't operate because they have to do visual inspections because they can't oversee the whole thing, then you were still affected, right? Yeah, your componentry may not have gotten it, but you're losing revenue, and that's what you're trying to avoid. So, and in same case, some of these things provide natural resources to entire cities and communities, and to have to divert and use other avenues, it's a cascading effect. So you can't really take that viewpoint, which kind of brings me into that question that Ann is asking you, Eric, about the separation. I can tell you, and this is my personal opinion, not CISA's. I've been in IT and OT for close to 38 years now. And I can tell you, if I have a way of keeping them separate at this time, I would. Now, with the technologies that I'm aware of that are in development, it may not have to be that way too much longer. I don't want to go into that. But I can tell you that we're working diligently on that front. And that's where your taxpayer dollars are going to try to get to this point where it's not as onerous so that you don't have to turn logging on every single device and then have somebody run out and collect it. That'll all be done autonomously via some type of semi-intelligent device. So just know that we are working that avenue. And at this point, my personal recommendation, some of the best systems, because I've seen it already in several instances of these attacks, they were able to bring their systems, their production back online manually, and that brings in their revenue while they fix the back end IT infection issue. So it's your call, obviously, out there in the field. You do what you have to do to make your investors happy. Obviously, safety of personnel is of the utmost importance. No amount of money can replace a person. So remembering that always, I pass back.
Okay, well, you're in one of my little pet areas as well, though. I'm a big believer. I mean, I come from the metals industry. It was steel and aluminum and things like that. Spent many years in that industry. And, and in the plants with the automation system. So one would say I'm an automation guy, an ICS guy, an OT guy or something. But what I learned over many years is unless the IT systems are working as well as the plant might be able to produce a piece of steel, and you may not explode something, you may not damage something, you may not destroy equipment, but if you don't have information from the IT systems, you can't run the plant. Nobody's going to build a car and not know what color upholstery goes in it. So you can't separate the two anymore. So anyhow, I just got a little note here saying that the time is up, and we've got to be pretty prompt here because we have another session coming up pretty soon. But anyhow, I want to thank our panelists. I thought this was an excellent session. I hope all the attendees did. Very informative. I encourage you to see the other session that Eric, which is with Brian Owens from OSIsoft. But then Dulles also has a booth here, so please visit that. And go to CISA or CSIA. I never get that right. I apologize if I got it wrong again. And also Dragos. I just want to, again, they did a wonderful job of not being promotional. I'll be promotional for them because I appreciate it. So anyhow, I want to thanks to everybody. And I guess we're going to be done with the session. Thank you so much for taking the time to participate with us. We'll see you.
Thank you, Sid.
Thanks, Sid.
Thank
Great
you.
session.